So a few lessons ago, we mentioned that the electrons in an atom are found outside of the nucleus, and that was the extent of the information I gave you. Last lesson, we talked about the fact that electrons are not just randomly outside of the nucleus, but rather they exist at certain distances from the nucleus, and these things called energy levels. So now we can take it a step further. So within each energy level, the electrons are found somewhere, and that's what we're going to talk about here. And we're going to write something called electron configurations. The electron configuration of an atom shows more precisely than what we've done so far where the electrons are in an atom. And it shows a couple things. It shows two things, in fact. The energy level that the electron is located in, and something called sublevel. So we'll get to that in just a second. So electron configurations are concerned with two things. There's two things we're looking at. The relative energies of each of the electrons in an atom, and then the capacity of each energy level for holding electrons. So again, each energy level can hold so many electrons. As we'll see in a little bit, each of these things called sublevels can hold only a certain maximum number of electrons. A couple reminders for you. Principal energy levels, I usually just call energy levels. Sometimes they're also called just principal levels. The capacity for any energy level can be found by using 2n squared, where n is the principal level. So we talked about that last lesson. Energy increases as you go further from the nucleus. So the energy of an electron increases as it's further and further from the nucleus, or we say that these energy levels, energy increases as distance from the nucleus increases. And then when we're writing electron configurations, when we're adding electrons to an atom, so to kind of building them, so to speak, the electrons will occupy the lowest. I'm going to put a couple things here. Lowest energy level first. In fact, the lowest energy sublevel first. And again, this will make more sense when we start doing some examples. All right, so speaking of these sublevels, there are 4 sublevels. This is for ground state atoms. It gets a lot more complicated when we talk about atoms that are not in the ground state. And so their names are letters. So we have S sublevel. The name that corresponds with the letter is not important. So S comes from spherical. We have P sublevels, D sublevels, and F sublevels. For this class, we will not be dealing with any electrons in F sublevels. Now, something else to keep in mind is that not every one of these sublevels is found in every energy level. So we'll see examples of that as well. All right, as I mentioned before, when we're adding electrons to an atom, we want to add the electrons to the lowest energy level available. We also want to add electrons to the lowest energy sublevel available. So in terms of relative energies of the sublevels, it looks like this. In any energy level, the P sublevel has more energy than the S, D more than the P, and then F more than the D. So S sublevel, lowest energy sublevel in any energy level. All right, so again, just as every energy level can hold only so many electrons, each sublevel can hold only so many electrons. So this is really important to remember these numbers, especially when we're writing electron configuration. So any S sublevel. Now keep in mind there's an S sublevel in every energy level. The first energy level has one S sublevel. The second energy level has one S. The third energy level also has just one S. And the S sublevel in any energy level can hold a maximum of 2 electrons. That's it. P sublevel. The P sublevel, as we will see in a minute, starts in the second energy level. So the second, third, fourth, fifth, they all have P sublevels in them. All of them, each of them, can only hold a maximum of 6 electrons. D sublevel, which actually starts in the third energy level, so there is no D sublevel in the first or second energy level. But the third, the fourth, the fifth, the sixth, all the D sublevels in those energy levels can hold a maximum of 10 electrons. And in case you're curious, the F sublevel can hold a maximum of 14. So we're going to skip letter D. There's some figures in your book that you can look at. Pages 117 shows the capacity for holding electrons. Pages 119 and 120 show the different sublevels and the different energy levels. And so you can refer to those on your own time. If you want to use that space underneath letter D for some examples, you can do that, or put these in the margin, separate sheet of paper. We're going to do some examples of electron configurations. If you want, you can start by writing this. So I've made a list of the sublevels, and we're going to start from left to right. So we always start by adding electrons to the 1s sublevel. So we have two things in an electron configuration. We have numbers and letters. And so you'll hear me say this often. Anytime you hear the words electron configuration, think numbers and letters. So these numbers, those are known as coefficients, and those coefficients represent the energy level where the electrons are located. The letters, S and P and D, represents these sublevels. So again, we always start by adding electrons to the 1s sublevel. It is the lowest energy sublevel available in any and every atom. So let's start off simple. Let's start off with hydrogen. Go to the periodic table, find hydrogen. How many electrons does hydrogen have? Now remember, that number above the symbol, the atomic number, represents the number of protons. If we have a neutral atom, that also represents the number of electrons. So hydrogen has 1 electron. So let's show where hydrogen's 1 electron is located. So we always start literally every single electron configuration for ground state atoms starts with 1s. Now we need to show in the electron configuration that in hydrogen, it has 1 electron in its 1s sublevel. To do that, we're going to use a superscript. Now it's not an exponent because this is not math. This is just a superscript. So superscripts, make a note in your notes, superscripts represents the electrons in these sublevels. So the electron configuration for hydrogen we read as this, 1s1. Hydrogen has 1 electron in an s sublevel in the first energy level. That's what the electron configuration tells us. So first energy level closest to the nucleus, s sublevels of particular type. We'll get into more details later on, and it has just 1 electron there. All right, let's take a look at helium. How many electrons does helium have? Again, go to the periodic table, and you'll find that it has 2 electrons. All right, so let's show where helium's 2 electrons are located. Again, we always start by filling the 1s sublevel. So let's start with that. How many electrons does helium have in its 1s sublevel? It has 2. Please, please, please do not read this as 1s squared. It is not an exponent. That is a superscript. The electron configuration for helium is 1s2. All right, let's keep going. Let's go to lithium. How many electrons does lithium have? Find it on the periodic table. And please pause if you need to while you're searching for things, because I'm just going to keep talking on my video. Lithium has 3 electrons. So let's show where each of those 3 electrons is located in this atom. So we start with the 1s sublevel. How many electrons does lithium have in its 1s sublevel? That is not right. Why not? Let's go back here. What is the maximum number of electrons that can fit in any and every s sublevel? The maximum is 2. So anytime you're writing an electron configuration, the largest superscript you'll use after s is 2. but we still have more electrons. Lithium has another electron. So how it works is you fill up sublevels and then you move to the next one. So fill up the 1s. What is the next sublevel to fill with electrons? Well, look at our list there. It is the 2s. How many electrons does lithium have in its 2s sublevel? Has one more. All right, let's try something maybe a little more complex than just 3 electrons. Let's write the electron configuration for, I don't know, carbon, let's say. How many electrons does carbon have? Pause the video if you need to. Carbon has 6 electrons, so we're going to write the electron configuration, meaning we're going to show where those 6 electrons are located. We always start with the 1s sublevel. We have 6 electrons total to place, so we're just going to fill up each sublevel and move on to the next one. So carbon has 2 electrons in its 1s sublevel. Next to fill is the 2s. Again, s sublevel, maximum of 2 electrons only. Whether it's a 1s, 2s, 3s, doesn't matter. And then what sublevel fills after the 2s? If we look at our list, the next one to fill is the 2p sublevel. Well, how many more electrons do we have? We only have 2 more electrons. So we get that for carbon. So carbon's electron configuration we read as 1s2, 2s2, 2p2. All right, let's try another one. How many electrons does sodium have? Pause if you need to. Sodium has 11 electrons. So again, let's show where they're all located. Let's start with the 1s sublevel. Fill it up. Then go to the 2s. Fill it up. After the 2s is the 2p. Now be careful. How many electrons maximum can fit in a p sublevel? If we go back to our list here, we see that the p sublevel, any p sublevel, including the second 2p sublevel that is, can hold 6 electrons. So let's fill it up. How many is that so far? I think that is 10. So we have 1 more electron. So which sublevel fills after the 2p? It is the 3s. And sodium has 1 electron in its 3s sublevel. So we get 1s2, 2s2, 2p6, 3s1. Let's try something a little more complex. Let's write the electron configuration for iron. Notice something. Iron's symbol is not I. That would be iodine. So iron symbol is Fe because of its older Latin name, ferrum. So be careful with the elements that have symbols that don't correspond with their names. Examples that come to mind are gold, silver, sodium like we just saw, that was Na, I didn't mention that before, potassium, mercury, copper. So all of these elements have symbols that do not correspond with their name. Tungsten would be another example, so be familiar with those. All right, how many electrons does iron have? Find it on the periodic table. Pause if you need to. Iron has 26 electrons. So again, just like we did before, we're going to add electrons to sublevels, filling them up, and keep moving to the next one. So we start with the 1s, then the 2s, then the 2p, then the 3s. What comes after the 3s? That would be 3p. Make sure you're counting the electrons along the way so you don't add too many. What sublevel fills after the 3p? It's 4s. How many is that? That is 20 electrons. We have 6 more. What fills after the 4s sublevel? 3d. So notice it goes in numerical order sort of until we get to that 3d. We see the same thing with the 4d, so just be careful there. So the electron configuration for iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Let me give you some to try on your own. I'll write them out and then you can work on them. All right, go ahead and work on these, just a few. I can give you some more if you want later. Pause the video and then we'll compare answers. All right, compare your results to mine. Again, we can do more. I figure we'll stop at gallium, but what if we did something like barium? How many electrons does barium have? Find it on the periodic table. Barium has 56 electrons. We'd have to fill up all these sublevels until we got to 56. So, question for you. Do you need to memorize this list? 1s, 2s, 2p, 3s, 3p, 4s, 3d. What if I said there was an easier way to write an electron configuration? Would you be interested in learning about it? Let's take a look. What if I said you can just use the periodic table to write an electron configuration? Here's how it works. First of all atoms that we will be doing at first will be in the ground state, as I mentioned before. Here's where there's a relationship between the periodic table and electron structure. You just thought it had these elements in there. It's got this particular random shape. The shape of the periodic table is not random at all. The periodic table tells us something about the electron structure of each atom. It's pretty amazing. Here's one thing. Each row on the periodic table, also known as a period, so we're talking about the horizontal rows, not vertical columns, horizontal rows. There are 7 of them on the periodic table. The 2 down at the very bottom, those aren't really their own rows. They're part of the bottom 2 rows. But each row in the periodic table corresponds to the beginning of the filling of a new energy level. Each row on the periodic table corresponds to the energy level that the electrons are in. So the first row in the periodic table corresponds to electrons in the first energy level. Second row in the periodic table corresponds to the electrons in the second energy level, and so on. As we saw in the list I gave you earlier, the D sublevel is 1 behind the row number that it is in. So that's why we go from 4s down to 3d. For the F's, that would be 2 behind the row number that it is in. There's a figure in your book similar to this one. It's on page 152. So the first 2 columns are also known as groups, are the S block. So these 2 here. And then this middle section is the D. We have P's, and then down here F. Notice that this here technically belongs over here. Let me ask you something. How many columns wide is the S block? It is 2 columns wide. How many electrons maximum can fit in an S sublevel? That would be 2. How many columns wide is the P block? Count them. Oops, missed it there. There we go. It is 6 columns wide. How many electrons maximum can fit in a P sublevel? That would be 6. Take a guess. How many columns wide is the D block? Well, the D sublevel we know can hold 10 electrons, so I'm going to take a guess and say that the D block is 10 columns wide. So this corresponds to electron structure. Here's how it works. You're going to start in the top left, go to the right, and then when you get all the way to the right on the periodic table, go down to the next row. Here, down, here. Keep going, all the way to the right, down to the next one, here. Notice there's no D's here. Here, 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 and here. Let me show you an example of what I mean. Let's use a periodic table to write sodium's electron configuration. Starts here. So we have also these row numbers, 1, 2, 3, 4, 5, and so on. So we start here with 1. We're in the S block. 1s. Here's the first position. Here's the second position. Remember, this really belongs over here. So 1s2. Then we come down. 2s2. 2p6 all the way through. Back over here, down a row. Now we're in the third row. 3s. First position in the S block. 3s1. 1s2. 2s2. 2p6. 3s1. Let's take a look at a different element. Let's use a periodic table to determine the electron configuration for manganese. I've written it out on my periodic table here. So read with me, please. 1s2, 2s2, 2, right, still in the second row. 2p now, p block, 2p6, 3s2, all the way through. Still in the third row, 3p6, all the way through. 4s2. Be careful, remember the D's are one behind the row number we're in. So though we're in the fourth row here, it goes 4s, 3d, 1, 2, 3, 4, 5. Let me read that again. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. All right, let's try this one out. This one's maybe a little trickier. Write the electron configuration for the calcium ion. Now we talked about ions. Think about what that +2 charge means in terms of its structure, not how it forms, in terms of its structure. By structure, I mean how many protons and how many electrons it has. Pause the video and determine how many electrons that ion has. So calcium ion has how many protons? That would be 20. How many electrons? That would be 18. What else do you know of that has 18 electrons? Argon. Remember, when calcium ionizes, it does so to become like argon, which is right here. So the calcium ion and argon are isoelectronic. Meaning they have the same electronic structure. So let's use a periodic table and see what that is. 1s2, 2s2, 2p6, 3s2, 3p6. If you count that up, that's going to be 18 electrons, same as the Ca+2. That's what we're looking at. Let's try one more. Write the electron configuration for the sulfide ion, it's called. The ion that forms from sulfur, sulfide. Pause the video and figure that out. How many electrons does this ion have? Well, sulfur, the neutral atom, has 16 protons. That -2 charge tells us it has 2 more electrons, 2 more negatives than positives. So that's 18 electrons, just like argon. 1s2, 2s2, 2p6, 3s2, 3p6. All right, let me know in class if you would like to do some more examples. Thanks for watching.